Okay, in geometric probability, we need to understand some basic shape areas, and I hope you remember how to find the area of a triangle. So if I have a triangle, that is an ugly triangle. Hold on a second here. If I have a triangle that has a base of 8 and a height of 6, what's its area? Figure it out. And let's say it's in meters. Would you put your answer in the right kind of units? Write down your answer and circle it and turn your iPad my way so I can see what you said. I'm seeing these really small numbers. Why am I not getting 48? Why shouldn't I get 48? Because it's divided by 2. Very good. 24. And some of you had it right. 24 meters what? Squared. Don't forget the little squared part, because these are in little squares. How many little squares would cover this thing is what we're talking about, etc. All right. So how about this one? Do you remember the area of this one? If it's 12 and this is 5, no wait, let's make it a nicer number. Let's make it a 6. And this height here is 5. What's the area of that? Don't say it. Write it. Let's say it's in inches. So obviously it'll be in inches squared. Please figure out the area. Circle it. And turn and look at the kid next to you and see if you get the same thing as them. A lot of different answers, huh? Who's confident? Who feels like, I'm pretty sure I got it right? There's nothing wrong with being confident. Think that's it? Not confident? Okay. All right. Well, then you're going to learn something. To do a trapezoid, and this is one you have to know for the ACT test, by the way. So this could cost you 1 point on the ACT, which means, oh, I'm not going to be able to get into Harvard after all. Okay. So seriously, it can come down to something like that. So anyway, we need to know average the bases, and then times by the height. That's a base. That's a base. See, if I use 12, 5 times 12 would be too big. If I used 5 and 6, 5 times 6 is 30, and that'd be too small. So what I do is I average these two. And instead of using 12 or 6, I add them together. Makes 18. Divide by 2 makes 9. And then 9 times 5, the average of the bases is 9. And times it by the height. Final answer, 45 inches squared. Did anybody have that? Awesome. 5 of you knew that. Way to go. Okay. One more area. Shouldn't be too bad, but I'm going to throw a little bit of a curveball. Notice I gave you the diameter. Figure out the area of that. And yes, you may leave your answer with a pi in it. Your answer may have pi in it. Because that keeps people from saying, but I use 3.14159265535. And somebody else saying, well, I use 3.14. Well, if you just leave the pi symbol in it, you'll all get the same answer. Yes, ma'am, you got an answer? Tell me what to do. Just tell me what to do first. Excellent. So you're going to only use this, which is 4, and that's the thing I was going to try to catch some people on. And then what? You got it. 16 pi is the final correct answer, except I probably should have units, but I never told you any. So 16 pi. That's called an exact answer. Do you get, as soon as I use 3.14 for pi, it's not exact anymore? So if I ever use 3.14 instead of pi, I'm going to get a rounded answer. So this is an exact answer. It has pi in it. All right. Good enough on the areas of things. To be able to understand this, you needed to know those areas. So now we're going to talk about geometric. By the end of the period, you will be able to define geometric probability and be able to calculate it. So to define it, it's this. This is what geometric is. And basically, it's the area of what you want over the area of what was possible. Notice that's the same thing I've been saying for probability the whole time. What you want over what's possible. So, the desired region, what you want. All right, looking at this, the desired region, let's just find the geometric probability of a dart thrown at random will land in the triangle, assuming it'll hit the trapezoid. All right, so here's what the assumption is. You're going to hit this thing, bam, like right there. Okay, it's going to hit it, and it assumes you're going to stay inside the trapezoid. That's a big assumption. but assume for a second that you'd have to hit that for sure, then what's the probability you're going to hit the yellow thing? Is your gut from looking at it that that yellow thing is 50% or less or what? Would you please write down a decimal and put down what your guess is? Do you think it is a 0.5% chance? Do you think it is a 0.6%? Maybe 0.4%? Figure out what you think the probability is. Just guess. All right, you got a guess? Is it written on your screen? All right. Turn, show the person next to you. See if you're higher or lower than them. I want some proof that later somebody will say, well, I had that, and I want to know if they had a witness. Okay, the yellow thing, do you think there's a half chance, a 50% chance, or less? I think, personally, it's more like a 40% chance. That's my guess. Who went less than half? All right. And now here's the question. Exactly what is it? It's the area of what I want. I want to hit the yellow thing over what's possible. What's possible was the whole thing. Well, what's the area of the yellow thing? It's base times height divided by 2, or 1/2 base times height. And what is the base of that yellow thing? Come on, what's the base of the triangle? 6. And what's the height of the triangle? 8. So 1/2, 6 times 8 goes on top. What's the area of the whole thing? Well, we just talked about it a second ago. You average the bases, and you times by the height. The average of the base, here's a base, here's a base. What do you get when you average them? No, 16 is when you add them. What do you get when you average them? 8. So the average base times by the height. Average base was actually 8 times the height is actually 8 equals 64. So what do I do with this 1/2 times 6 times 8, which turns out to 3 times 8, which is 24, divided by the 64. And yes, it's definitely less than half, isn't it? If you haven't already, get the graphing calculator, or get the calculator app up in the iPad. Because on today, I can't use the graphing calculators anyways. You can use them if you want to, but I want you to have the calculator app on the, I think it's in self-serve if you haven't already downloaded it. I think some people went to like the self-serve thing and just downloaded everything that was there. If you did, cool, you've got it. But if you haven't already got the calculator app, get it. It's free, of course. I didn't think we have to pay for it either. It was a free app. Yes, sir.
Does it matter which one?
All we're doing is dividing two numbers, so I don't care which one you use. But you're right, there are multiple apps. All right. So, did you get 0.375? Raise your hand if you did. Okay, good. It's what you want over what's possible. This is what I wanted, the yellow triangle, and this is what was possible, the whole trapezoid. All right, this one is a little harder. This one, I want you to use your response app that we made yesterday. Remember that one-touch button we made yesterday that would allow you to go into response, instant response? Did I do that in your class or not? Awesome. Okay, I'm going to pause for a second while you find that recording again. All right, so on this problem, we're talking about the probability the goat is going to eat the dandelions, and the dandelions, the thing we want, is 15, out of what's possible. Well, the goat can walk all the way around here in a circle, but oh, he hits the wall there. And he can walk around here, but he's going to hit the wall there. Do you get that it is not a whole circle? All right, do your best to figure out the final answer and divide it out of the calculator, and then type it in to your response app. And tell me what you think the answer was. It'll be a decimal. I'll tell you it's a pretty small one. Give me 3 decimal places, like 0.002 or whatever it is. Here's the most common mistake answer I'll keep you from making. It's pi r squared, right, for the area of a circle. And what's the radius of this thing? 10. And 10 squared is 100. And 100 times pi is 3.14. Totally okay to use 3.14 for that. So 3.14 times 100 is 314. That's the most common mistake answer. What's wrong with that? Can the goat actually eat from the entire circle? No, he gets blocked by the barn. So it's got to be less than 214. And then the next most common mistake. I guarantee you if I go look at my answers. I'll find those. So I'm going to go take a look. I'm going to pause for a second while I go look at my instant answer. Okay. So we need to take this 314 for the circle, and we need to now take something off of that. We need to take this into account. And a lot of people go, oh, we'll take away the barn. The barn's 100 minus 100. Wrong. Why can't you take off 100? Because the barn goes outside the circle, doesn't it? See? You can't take off 100. It's 314 minus something. Here's another way to think of it. What percentage of the circle can the goat walk on? Half the circle? 3/4 of the circle, yes. So how do you do 3/4 of your 314? You go 3/4 of means times 314. If you can actually get this done correctly, type it into response app. I'll see a lot of the right answer, and then I'm going to let you go to lunch, but I got to see some answers here. I'm going to pause while I go look at my answer. All right, so this one came out to 0.064 after we took 15 divided by 235.5. That was the part of the circle that the goat could actually walk on was 3/4 of the circle. Go. All right, so we're back from lunch, and we were doing geometric probability. Again, it's the area of what you want over the area of what was possible. So this problem is awful, and we're going to skip it, and we're going to skip it on the homework also. When you see number 16 on the homework and it's like this, we're skipping it because there's a lot of problems with how it was set up. If it was as simple as, you're going to land inside the rectangle, what's the probability you will land inside the trapezoid? Now that would be possible. So I'm going to change the question to just be that, ignore all the other words around it, and use the sides of the little box and just count them and go, okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 this way, and you do the rest of the counting. And I want you to figure out what's the probability that you'd land inside the shaded box. That's all I want to do for this one. All this other stuff, we tried to make it neato complicated, but it really actually is impossible the way it's written, because technically the points that are on the line shouldn't count, and it's complicated. I feel like I smell bacon in the hallway. Does anybody else smell it? Smells kind of good. What is the probability, if you're going to land inside the rectangle, that you would also land inside the trapezoid? So the shaded region is what you want. All right, for this one, I'd like you to just write it on your iPad, turn it my way so I can see what you said for an answer. Give you another 30 seconds to figure it out. All right, now we're on to contingency tables. So on this contingency table, this is like a last review question here. If you choose a random person from this group, what is the probability you'll get someone who is infected with cholera? As soon as they say choose a random person from this group, I said a random person, it could be anybody, and then you take the biggest number possible. So it's out of 818. And then what did we want? Because that goes on top. The person who was infected with cholera. I don't know why you'd want that, but apparently maybe you want to like try to help save them or whatever. Okay, so that would be 69 of them. So do you get how that was 69 over 818? All right, do the harder one for me and show me what the fraction is by turning your iPad towards me. So go ahead and open the iPads again and try that last question. Write me a fraction. Zoom in so it's really big. Zoom on in your answer. All right. I'm seeing lots of answers. Check, check, check. I'll tell you in a second if you're right. Thank you. Thank you. Thank you. Still waiting for several of you. Thank you. Thank you. Okay, that's a decimal. Can you make the fraction? Could just go back to the fraction because I don't know what the decimal is. Okay. 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 Registered that vast majority of you had it right. If we're only choosing from people who were not infected, that means we're only picking from these. Can't pick these, can't pick these. If you used any of those numbers, you screwed up. It's out of 749 then. And then what do we want? They were inoculated. The very end is usually where you get that. They were inoculated, which would be these guys. So 276. Raise your hand if you had that one right. Okay, good. So that's just a reminder on how to do the contingency tables. So back to our goal for today, which was to make sure you understood what the area model was. It's this. The area of the desired region over the area of what's possible. So it's, again, what you want over what's possible. And you were supposed to feel confident that you could do a problem like this. So let's just do one last real quick problem. This is 8, and this is 9, and the radius of this puppy is 1. I'd like you to figure out the probability that you're going to hit inside the circle if you know you're going to stay inside the rectangle. If you're dropping something from really high up and you know it'll go in the rectangle, what's the probability it'll also go in the circle? You can use 3.14 for pi. I can't believe. Oh. All right, so there's your answer for this one. The top is 3.14 because that's the area of the little circle, over the bottom, which is 72. 9 times 8 is 72. Divide them, and you've got your answer. Have a good day.